Well, welcome everybody. Thanks so much for joining me today. My name is Brandon Minnick, and in this session, we'll be talking about an introduction to serverless with AWS Lambda in C#. Now, I'm really excited to be here talking about this with you today because I love serverless. It's a topic that's really near and dear to my heart, so hopefully you'll catch the bug that I caught and love it too. But I'm actually a mobile app developer. I make iOS and Android apps in C# using Xamarin and now .NET MAUI. And I've been publishing apps to the App Store for about the last 7 years. And when I make my apps, it's just me. I'm just the one guy. I make these on nights and weekends. I do it for fun. And if you find my apps in the App Store, they're totally free. I don't charge any money for them. There's no in-app purchases. And so when I needed a solution for my backend, because let's be honest, every app needs a backend, I needed something that would be easy for me to maintain, easy for me to implement, kind of something that's set it and forget it, but also something that's kind of cheap, because I don't have a lot of money off the $0 profits that I'm making off these apps. And so that's when I found serverless. So we'll get into all the goodies of serverless and how we can be an individual developer like myself, still have a whole backend running in the cloud, and still be maintaining and building and publishing our apps, all thanks to serverless with AWS Lambda. Now, before we get going, I want to point out 2 links that you'll see at the bottom of just about every slide today. Make sure to take out your phone and grab a picture of these links at some point, because down here on the bottom right, this is a web page that I've made just for this session today. This contains everything that we're about to cover. So you don't have to worry about memorizing anything, because if you go to that web page, this is where you can find the slides. This is where you can find all the code. I have an end-to-end open source sample that we're going to show off in just a little bit. And I've also included a bunch of links to helpful resources that I used when I was first learning about serverless and Lambda and C# and all that fun stuff that should be helpful for you too as well. Plus, these sessions are recorded, so once NDC posts the video on YouTube, I'll make sure to add the link there as well so that you can share it with your friends, your colleagues, anybody else who couldn't make it today but maybe is excited about serverless as well. And then on the bottom left, that is my Twitter handle. This is the best way to get in contact with me. So if you have any questions, we don't get a chance to chat later on at the conference, or if you just ever want to chat about C#, Xamarin, MAUI, serverless, AWS, whatever, feel free to come join in the conversation. Now, this is introduction to serverless. So what is serverless? Lately, serverless has kind of become this buzzword. We probably hear it all the time, like serverless, microservices. And if I'm being honest, it's kind of a weird term, because serverless implies that there's no servers involved. And that can't be true. The laws of physics state that if we're going to run code, that code's got to run on a server, right? That code's got to have a CPU. It's got to have memory. And so nothing's actually truly serverless, because then we wouldn't have any code running. So I found that a better way to think of serverless is actually less server. Because yes, your code will still be running in the cloud on a server, but with serverless, it means that our code isn't running 24/7. We don't have a dedicated server given to us by AWS that they're charging us every second for, because we said, we need a certain amount of CPU cores and this much memory. And so if we had that, that wouldn't be serverless. Serverless, we basically are able to publish our code to the cloud, and then whenever it's needed, it spins up that server and it runs. So with serverless, we just have less server to worry about, less server to pay for. Our monthly bills will be a little bit cheaper, less server to maintain, so we don't need a team of engineers to make sure that our server's up and running all the time, that our server's scaling properly. Serverless takes away all of those worries from us so that we can just write our code and run it in the cloud. Now, to really understand serverless, let's go all the way back. Let's go back to the days of on-premises. Now, I don't think I've been around that long. I've been in the industry for about 15 years. But when I started, this was all we had. There was no cloud when I started working at my first engineering job out of college. The company I worked at, we just had a giant data center, the size of a football pitch with just rows and rows and rows of racks, and every rack would be filled with servers. It'd be freezing cold in there because servers generate a lot of heat, so you got to keep it really cold. It's really loud from all the servers that are running and doing all their computations. And I remember if I ever needed to do something, like let's say we were building a new app, well, the first thing I would have to do, I would have to get a server. So back in the day with on-premise, I would first have to go to procurement and say, I need a new server. I need it to be this many CPUs, this much RAM, and they go, great. The lead time is 6 to 8 weeks. So about 2 months later, I would have a server appear on my desk that once it would show up, I'd grab that server, I'd walk it down to the data center, I'd find an open slot in a rack and stack it, bolt it in, connect up all the cables, and then once I could finally turn it on, well then, I got to install the operating system. So we were using Linux a lot at the time, so install the latest version of Linux, make sure to get all the security patches installed from the IT admins, work with the networking team to make sure that we have our firewalls in place, and then I can communicate with it. And then finally, I could actually publish my code to the server and we could run it. So with on-premises, it has a lot of I don't say problems, but definitely a lot of questions, a lot of concerns. You also need a real big team of engineers to maintain this stuff because you need the engineers like us who are going to be writing our C# code, but you also need the team of engineers to maintain these servers. We need IT admins to keep the operating system up to date. We need our security administrators to make sure that we're patching any vulnerabilities. We need our network administrators to make sure that our firewall's in place and we're not going to get DDoSed. And then on top of that, we need physical security. That building had big barbed wire fences all around it so nobody could break in and damage the servers or worse, steal our data. And so big costs, lots of stuff going on, and we have to have this huge team to manage all of this just so I could build my app. And on top of that, our workflows, our timelines, we had to plan months, years in advance if we just wanted to publish a new app because we had to plan for that 2-month lead time for the server to come in. We had to plan for about a week or two to get that server just up and running. We had to do security audits. And so it wasn't simple, and anywhere along the line, any part of that chain could break, and then all of a sudden we're slipping our deadline for publishing our new app for weeks, if not months, if not years. So thankfully, a little while later, AWS came up with this great idea called IaaS, Infrastructure as a Service, where they said, you know what? You don't need a data center. Just tell us how much horsepower you need, how many CPUs, how much RAM do you need, and we'll spin up a virtual machine for you in the cloud. And this was great, because now we went from all those problems where we had to have the physical data center, and we had to order in stuff, and we had to worry about supply chain issues, and we had to have physical security, to now, with a couple clicks of the mouse, I can just spin up a virtual machine in the cloud. So great, we don't have to worry about as much stuff anymore, but really we still need a big team of engineers, right? Because it's still just a virtual machine. It's still our responsibility. We still have to install the operating system. We still have to keep it up to date with security patches. We still have to do the networking, the routing, the firewalls, all that fun stuff. And so we still have the same core engineering team, but instead of just monitoring a server here in our data center, they're monitoring that same server in the cloud. So IaaS was a good step in the right direction. It still works really well today. But then the concept of platform as a service came about. Platform as a service, or if you're using AWS, it's called Elastic Beanstalk, is really cool because now this takes away the whole worry about the operating system. So now I don't have to worry about what operating system am I running on, what version of it, what are my security patches, what's my networking, what ports do I have open, what ports do I have closed. With PaaS, I just tell it that, hey, I want to create a web app or maybe a web API or a website. Here's my code, publish it to you, AWS, and then you run it in Elastic Beanstalk and you take care of all that for me. And the only thing I have to do is kind of keep an eye on it, because I'll tell it that, I want 6 CPU cores, I'll tell it that I want 32 gigs of RAM. But if at one point I get a whole flood of users and all of a sudden my server is hitting 100%, I want to make sure that scales up. And then I want to make sure that we don't use too many resources and we're overpaying. So PaaS is great because now, again, we don't have to worry about the operating system stuff anymore. We don't have to worry about the networking stuff. All of that is abstracted away from us. So again, we can focus more on our code. But we do still have to monitor this server. We have to make sure it stays up and running. We have to make sure it scales to our users' demand, and also make sure we balance that with whatever our costs and whatever our budgets are. But now, finally, we get into serverless. So serverless takes that one step further. It takes the idea of PaaS, the idea of that Elastic Beanstalk had, and goes one step further and says, what if you didn't even have to worry about how many CPU cores you needed? What if you didn't even have to worry about how much RAM you needed? What if you just gave me your code and we run it in the cloud for you? That's basically what serverless is. So with serverless, all I have to do, I write my code. In Visual Studio, I'll just right-click it and I'll publish it up to AWS, and then it's running. It's there, it's ready. It'll scale up as my user demands. So if I have a bunch of users all hit the back end at the same time, it'll scale up appropriately. And then if there's no demand, it'll actually scale all the way down to 0. And that's really where we can see a lot of the cost savings come in, because if nobody's using our app, well, our code's not running in the cloud, and if our code's not doing anything in the cloud, then we don't have to pay for anything in the cloud. And so this is where I really found that sweet spot for my backend for my mobile apps, because, like I said, I don't make any money on these apps, so I don't have a lot of budget, and I also don't want to worry about anything. I don't want to have to be managing servers all the time. I just want to make apps. And so with serverless, we can do that. It abstracts away all of those problems. We can just upload our code to the cloud and basically set it and forget it. Now, let's dive a little bit deeper into those topics. So why would we want to do serverless? Well, we're abstracting away the servers. We don't have to worry about CPU cores. We don't have to worry about memory. All that's taken care of for us. We don't have to worry about the operating system version, like maybe Windows just pushed out a new security patch. That's okay, because AWS is going to take care of that for us. We don't have to worry about any of that. Same with networking, routing, DNS. None of that is our concern anymore. Scaling. So like I mentioned, serverless will scale to meet whatever your user's demand is. So if we all of a sudden get an influx of demand because maybe some influencer starts tweeting about our app and we get 1 million downloads, well, serverless can handle that. As they start hitting the back end, AWS Lambda will automatically figure that out. It'll scale up appropriately. And then if all of our users go to bed and nobody's using it at nighttime, it'll scale all the way back down to 0, which means we don't have to pay any money because we're not using any resources in the cloud anymore. Love that. Now, there is a catch. Because it scales all the way down to 0, we introduced this concept called a cold start. And a cold start happens when we have 0 instances running because our backend's been idle, but then the first user hits our backend. And what's happening behind the scenes is, our code, our DLL file that we publish to the cloud, it's sitting there. A user opens our app, and AWS goes, oh, I got to quickly spin up a serverless instance. And so it launches the code and quickly spins it up. And that does take some time. So here's the latest metrics. So on .NET 6, on an ARM CPU specifically, it'll take about a second for your serverless instance to initialize if it's been idle. So the first user that hits your app after it's been scaled down to 0 and it's been a little idle will have about a second of cold start time. Now, maybe that's a lot, maybe that's a big deal, maybe it's not a big deal. That kind of is the balance we have to take into account when we're building our apps, because this is really critical to serverless. If your app always needs to have instant response time, maybe you're doing something real time like a game, or you're dealing with monetary transactions like stock market data, and if we wait to execute, we're going to lose money. Well, maybe serverless isn't the right choice. Maybe that's where you pay a little extra for Elastic Beanstalk. It's always up and running. It'll be responding instantly. No problems. But for me, as a mobile app developer, especially an Indian mobile app developer who doesn't get paid to make mobile apps, I was cool with this. And so what I did, if you download some of my apps from the store, when you launch them, you'll see this animated splash screen. So when the app launches, I display a nice little animation to kind of distract the user a little bit. So the user's not sitting there going, geez, why is this taking forever to load? They're just seeing this fun little animation play, and they go, oh, now the app's launching. And the good side is there's also warm start. So all the way here on the right, a warm start is, let's say I've just launched the app, I got the hit for the cold start time, but then you open the app. When you hit the back end, you're going to hit a warm start because that serverless instance is already up and running. So warm start, basically negligible, 10 milliseconds. I mean, I don't care about 10 milliseconds. Maybe that's a big deal to you, but with warm start times, we don't really have to worry about it too much. But again, with cold starts, something we want to take into account. Can we work around this? Is that 1 second penalty going to be detrimental to our users? Are our users even going to notice? Maybe, maybe not. But the good news is, every year, with every iteration of .NET, this cold start time gets lower and lower. So we have some numbers here from the latest version of .NET, .NET 7. .NET 7 was the first one to really introduce this concept of native AOT, which stands for ahead of time compilation. Long story short, C# apps have mostly been just-in-time compiled, meaning the compiler's actually running while the code's running. So that means it takes your app a little bit longer to start up because it's got to do a little compiling. But with ahead-of-time compilation, all of that's done at build time. So when you publish this app, all that compilation's already done, and that allows the app to load even faster. So with .NET 7, with AOT, now we're seeing times getting down to 200 milliseconds, and I expect this to just continue getting lower as .NET continues to improve, as AOT continues to improve, as we continue to build better with AWS Lambda and integrate with .NET and AOT. So keep an eye on these, because back in the day when serverless was new, these times used to be up in the seconds, like multiple seconds. And yeah, that was painful. But nowadays, 1 second, if you're still using .NET 6, not too bad. And then .NET 7 with AOT getting down into 200, 300 milliseconds. Now we're really getting into the point where it's like, well, maybe serverless is always applicable. Maybe it basically is real time. We don't have to worry about cold starts as much. Now, the benefit to all of that is this, what we call micro-billing. Because when you use stuff in the cloud, as if you ever used any cloud service, AWS, Lambda, GCP, they bill you for what you use. So if you tell them you want to reserve a virtual machine, well, they're going to give that to you, but you're going to be paying for that virtual machine 24/7, whether you're using it or not, because they have to carve it out and dedicate that to you. But with serverless, because it scales all the way down to 0 when you're not using it, well, that means we're not getting billed for anything. And so the back-end costs end up being really, really cheap. So these are my 2 apps that I have in the App Store. Shameless plug. Download them, try them out, give them 5 stars if you like them. I have an app called Git Trends that helps you monitor your GitHub repos. I selfishly made it for myself because I got a couple hundred GitHub repos. And with Git Trends, I wanted a place where I could monitor all my views, clones, stars, forks, issues in one place. And it'll even send you a push notification if you get a spike in traffic in one of your repos, which is really cool. So I've had that happen a couple times where somebody tweets out some code that I wrote, and all of a sudden 1,000 people are looking at it. And with Git Trends, I can go and see how much traffic is coming in and also where that traffic is coming from, so I can go back to that blog owner and shoot him a thank you for referencing my code. Pun Day, this is a fun game, so if you're into puns, I teamed up with a guy who created a website called mondaypunday.com, and he makes these drawings. He makes these drawings by hand, and each drawing is a pun. And so, for example, you might see a drawing of, say, a bear kind of hunched over a pottery wheel, and the pun there is Harry Potter. So if you're into puns, check out Pun Day. If you want to monitor your GitHub repos, check out Git Trends. Like I said, totally free to use. And here is my serverless costs. This is legit. I just pulled these numbers last night for my last billing cycle. I've got, they're not huge apps, a couple hundred monthly active users, but 14 cents a month, 14 US pennies for running a backend for Git trends, and then only 19 cents for punt day. Yeah, that's not too bad, right? Like, I can afford that on my $0 a month income from those apps. Now, one of the coolest things, and this is one of the things I love the most about serverless, is they're all event-driven. So we've probably been talking and thinking about mostly in terms of APIs, like our app has a Git API. Well, yeah, we can make a serverless Git API, and that's what we call an HTTP trigger. Under the hood, it's using AWS's API gateway. But all these other AWS services also can trigger and launch your serverless application. So you can write a serverless function that triggers anytime you add a file to S3. If you haven't heard of S3, it's just a big storage bucket. I like to think of it as like, if you have a folder on your desktop, you can drop a text file in that folder, you can drop pictures from your recent vacation in that folder. S3 is basically just a folder in the cloud. So you can put files in it, and you can have a serverless function that triggers anytime a new file's added. So let's say somebody's added a text file, you can immediately have your code trigger to, say, parse and analyze that text file. Maybe you're doing some machine learning on it or something like that. Likewise, like database triggers. So let's say you have an app where when you add a new user, we add a new row to the user database, and we can have DynamoDB trigger right away to do a couple things in the background. Because what's the worst thing in the world, right? Like when you're a new user to the app, you already have to make your accounts. You gotta use your email address, create a new password, great. And then once you're done with that, like you just want to use the app. You don't want to sit there and wait for everything to get verified. So what we can do as application developers is we could use something like a DynamoDB trigger, a database trigger, to fire off this stuff in the background. So we can verify their information while they're in the app and using it, and then we can just send them a welcome email, and they don't have to sit around and feel like the app's taken forever to get onboarded. So you get all these different types of triggers. There's even more than this, so highly, highly recommend checking these out, because this is where we start getting into the concept of microservices. So with microservices, you can start to see how you could have multiple serverless functions. And keep in mind, a serverless function is basically just a method. It's just one thing. It's just just a couple lines of code. It should only take a couple seconds to execute, a couple minutes to execute at the most. In fact, if it takes too long to execute, Lambda will actually kick you out. It'll actually turn off your serverless instance and scale it back down to 0, because if you need 15 minutes to do something, well, you probably shouldn't be using microservices. But we can have all these event-driven microservices that all fire asynchronously. They all scale up and down as needed. It's really, really good stuff. And this is what I want to get into to show you guys today. So I brought an end-to-end demo that we're going to show off and dig into the code, see how all this works. And this is what we're doing. Now, you may or may not know it, but a really common scenario in mobile applications is anytime you upload an image, what they're doing, they take that image and they downscale it, because phones are super powerful nowadays. So like the new iPhone 14, I think it takes 48 megapixel photos. So if you upload a 48 megapixel photo to, say, Instagram, if Instagram then served that same 48 megapixel photo to all of us, that means anytime you go and look at my profile, it would take forever to load, because you'd see one picture load after a couple seconds, and then the next 48 megapixel photo would load after a couple seconds. So what companies do, like Instagram, they immediately take that photo and scale it. So they'll scale it down to a point where it still looks good on certain devices, like they'll scale it specifically for mobile, they'll scale it specifically for web, for desktop, and that's what we see when we launch our app. So what I've made here is basically that workflow. I've created a mobile app using .NET MAUI and C# that takes our picture. Then we upload that picture to a HTTP trigger, a post API. That post API is going to ingest the photo that I upload, store it in our S3 storage bucket, and then once that happens, we'll have an S3 trigger kick off automatically. And that S3 trigger is called generate thumbnail, because it takes that photo that we uploaded and I scale it way down to just 200 by 200 pixels, put that back in the bucket, and then we've also added in a get API down here called get thumbnail, which is also an HTTP trigger. So let's check this out. So I've got the app running here behind me, or behind the slides, and it's made in .NET MAUI with, if you haven't heard of .NET MAUI before, it allows you to make mobile apps for iOS and Android in C#, but you can also make desktop apps as well, so macOS and Windows. So here I have my Android emulator. I'm going to click Upload Photo. We should see me come up in just a second. Oh. Maybe, maybe not. Well, I'll tell you what, let's click the Take Picture button. Oh, well, there's me dry running before I came here. I'll tell you what, let's pull it up on Mac. Looks like this Android emulator's going through some problems here. All right, so let's launch it here on the Mac, because we can do that since .NET MAUI allows us to make macOS apps as well in C#. There we go. All right, so we'll take a picture. Maybe? What happened? I wonder if the screen share is getting in the way of the camera. Oh, okay. Looks like we might have a picture here on Android. Come on, let's see. Upload something. Okay, cool. So if we uploaded this weird picture that must have been saved in the cache somewhere, and so right now, it's uploading that picture, so it's, oh no, did we lose internet access too? Oh, we're falling apart here, guys. Let's see. Let's see. Let's try restarting the emulator real quick. Let's make sure we can ping out to Google. That's working. Give it one more shot. If not, you can just take my word. I swear it works. Yeah, I'll bet something with the AV systems get in the way. But shoot. Well. Oh, wow, look at that. So it should be using my macOS camera to look at me right now. But I tell you what, well, I'll leave this running. Probably would have dressed up if I knew these pictures would show up. But let's take a look at the code. So what's going on here? We've got our mobile app, and the first thing it's going to do is upload that image to a post API that we've made using AWS Lambda. And so let's look at that post API. Oh, maybe. We'll keep poking the Android emulator. Maybe that'll work. But where are we? So here we go. So we have our upload image. We'll cross our fingers while that's spinning its wheels. All right, so here is the first serverless function that we're going to look at today. So this one is called upload image, and it's a post API. Hey, oh, look at that. It finally did it. Cool. So for whatever reason, this was me taking pictures like 12 hours ago, but you can see, so Android's actually stretching out the picture. If I zoom in here, you know, if you look along maybe my hairline here, you can see a little bit more detail than over here where everything gets really blurry because now this is only 200 by 200 pixels. So again, what just happened was we uploaded that photo and it was immediately dropped into this storage bucket. This S3 trigger kicked off automatically, created our thumbnail for us, put it back in the bucket, and now the phone's able to request the new thumbnail picture from our get thumbnail API. So looking at the code here, this is our upload image API. And you'll notice a trend as we kind of go through all these. The first thing we have up here is I'm initializing an Amazon S3 client. This is really cool because this S3 client well, A, it's free. This is just included in the S3.NET SDK in the NuGet package. But when I say new Amazon S3 client, when this code is running in the cloud, because my function's running in the cloud and I'm already inside, and it knows who I am, this S3 client also has all my credentials as well. So with that S3 storage bucket, it is completely locked down. If I gave you the direct URL to the image that we just created, you wouldn't be able to access it. Very, very secure, completely locked down. But since we're already in the cloud, and AWS Lambda knows all my credentials, and they know what resources I can access, when I just say new Amazon S3 client, that gets included as well. So I don't have to worry about managing security keys or credentials. I don't have to use any environment variables. I don't have to store any secrets and worry about accidentally committing them to GitHub, because just new Amazon S3 client takes care of that for me. Now, the serverless function is really right here. It's this one method called function handler. And this method accepts a API, gateway, HTTP, API, V2, proxy request. That's a lot of words just to say, this is the HTTP request that just came in. It is using AWS's API gateways, so that's why they add in some of that. And it is using HTTP 2, so that's why I get HTTP API v2. But for all intents and purposes, this is just the HTTP request. So this is where we can check the query parameters that come in. This is where we can, it's a post API, so we can get the data from the body. So what I've done here is kind of like how we would design any API, right? I first check the query parameters, because the way I've designed it, I have the mobile app include the file name as a query string. So if that query string isn't missing, I don't know what the file name is, so I immediately tell you, sorry, bad request, you're missing my query parameters. But if it's a good request, then we can start parsing that image. So we parse the data, I get the image, and then I have this method that I created called upload content to S3. And if we dig into this, so this uses that same S3 client that we we're just talking about, which is, again, logged in. It's got all my credentials just baked into that SDK by default. And so the other parameters this takes is a string for the name of the bucket. So your S3 bucket has a name. And the string called key, well, that's just the file name. So what you're going to name the file where you put it in the bucket. And then I made it generic so it can accept any type of content. And then also, we want to have our Lambda logger in here so we can write to the logs just in case. So what I do, I first look to see, is that content a stream? Which in this case it is. We're uploading our image as a memory stream. And if that's the case, what we're doing, we're creating a put object request. This put object request also is given to us for free thanks to the AWS S3 SDK. And so if we have a stream, we add that content as an input stream. But if it's anything else, we can just serialize that and put it in the content body of our object request. And then really all we have to do is say S3 client.put object async. So once we do that, we get a response back that lets us know, hopefully, that everything worked out okay, and the upload succeeded. Now the only thing I do, which is a little bit extra, is remember how I said our S3 buckets are just completely locked down? Like if I was on AWS right now and I could pull up the URL for that file and give it to everybody in this room, nobody would be able to access it because you don't have the credentials, and including me. I would have to give myself credentials to use that URL. But what we can do, we can generate a pre-signed URL where I tell it, create a URL for this specific bucket, this specific key, which is, again, the file name, and that'll last for, in this case, 1 minute. And then that URL is what I can send back to my mobile user. And now I give them a little bit of access into the S3 bucket, but only for a minute. But that's plenty of time for them to receive the URL and display the image on their device. This is also very similar. I don't know exactly how Instagram does it, but they also have, they generate pre-signed URLs as well. So if you ever try to look at an image on Instagram and then a couple days later go back to the same URL, it won't work because it has to be a pre-signed URL to give you access. So all right. So we've uploaded that content to S3 here in our upload image function. And then we've got the photo URI. And in that case, we can just return a response back to our user. So this is an API gateway HTTP2 API VC proxy response where we tell it that the status code is OK. And then what I do, I just serialize that photo URI and send it back to the mobile app so they can display that image on the device. Cool. So we've successfully uploaded the photo. That function has added it to our S3 bucket. And now what's going to happen is our S3 trigger is going to automatically kick off. So if we look at our code again, I've got a function here called generate thumbnail. And it looks kind of similar, right? Like, I mean, it's called generate thumbnail, but we're still creating a new S3 client. And we still have this method called function handler. But the difference here is we don't have that API gateway v2 request. We have an S3 event because S3 is triggering this serverless function. So what this code does, we make sure that the file exists, that nothing weird happened, it's not null. And then I do a double check here to make sure that the file name doesn't end with thumbnail, because when I generate the thumbnail, I take the same file name, and then I just append _thumbnail.png. So after I create that thumbnail, I have to put it back in the bucket, but then that would trigger this S3 bucket again. So this is how I can just make sure, like, OK, if you're already a thumbnail, we're just going to return. We're not going to do anything with you. And then down here, pretty similar. We're going to tell our S3 client to get us that object. So we pass in all the info that we just got from our S3 event up here. And it gives us our bucket name. It gives us the name of the file, the key that was added. So we get that response back. Of course, we got to make sure it's good. Otherwise, we can't move forward. But once we have it, then we can copy that response stream into an image, and we can start manipulating it. So down here, I have a method called getPNGThumbnail, where I'm using a cool library called ImageSharp that does all this image resizing options for me, which is great because I had no idea how to do it. I basically just copy-pasted this code from the ImageSharp library, and happy days, look at that. I can just tell it to resize to a 200 by 200 pixel image, tell that image to mutate specifically to resize it. Then we save that PNG to our new memory stream, and then we can return that back above to use it elsewhere. Now, the only other thing I need to do is generate that new thumbnail name. And like I mentioned, I just use that same file name that the mobile app gives me, and I just remove the extension and add in that suffix that we saw earlier, that _thumbnail.png. So now I know this is the same file, but it's my thumbnail version of it. And now that I have my image, here my thumbnail, I have named it. Well, now I can upload that content to S3. So I wrote this method that we just saw earlier, right? This is the same method. So we're just passing in that content. We're putting it in here as a stream or serializing it to the content body. Happy days, generate that pre-signed URL, and we're good to go. So this kicked off automatically. Once we added that first image to the bucket, it generated our thumbnail, and then we uploaded that image back, or the new image, the new thumbnail, back into S3 storage. All right. So the only one we haven't looked at yet is this get thumbnail. And this is a get API. So pretty similar to the post API that we looked at. It's still just a function handler. We're still taking in an API gateway, HTTP2, API v2 proxy request. And the only difference this time is we're not ingesting a photo. We're just going to give you the thumbnail for the image you're looking for, because the mobile device only knows the file name that it gave us. So it maybe uploaded the file called brandon.png. And so when it goes to load that file, it's going to say, hey, give me the thumbnail for Brandon. It doesn't know that I renamed that file and I've done a bunch of processing to it. So again, it gives me that file name as a query parameter. Assuming that's there, then we can move on. If not, we'll tell it's a bad request. But what I do is I say, OK, well, what was the file name you gave me? And I'll run that same code to generate the thumbnail file name from that. And then I'll call this s3 service.getFileURI method here, where what we do is, if you don't give me an expiration date, I'll automatically make sure that this URL expires in a minute. But yeah, basically we're just making sure the file exists, and then we're generating that pre-signed URL like we talked about earlier, and returning that URL back here. There we go, as our thumbnail URL. And that's it. And then this Get API is basically done. It's got the thumbnail URL. It makes sure it's not null, because if it is null, then we're going to say, hey, you told me to look for this file, and I couldn't find it. So 404 not found. But if we can, then we'll serialize that thumbnail URL, send it back to the device, so now it can display that image to the user on the screen. All right, so pretty cool stuff. Again, super powerful because all of this will scale independently. So if all of a sudden we have users uploading photos like crazy, well, Lambda will scale up accordingly. And if all of a sudden we have S3 storage is just inundulated with new files, then our S3 trigger over there will scale up accordingly. And it's all running asynchronously, so users don't have to wait. They don't have to worry about process times. They don't have to just see a spinning wheel on their mobile device, because there's nothing worse than just staring at a device that just says loading, loading, loading. So okay, so that's an example of how we can build a serverless architecture for our backend, but this is an intro class, right? Like, how do we even create these? Like, where did I even come up with this code? How do I know about that API gateway v2 proxy response? Well, what I highly recommend is when you're starting out, you're going to want to install this AWS toolkit. So there's an extension for Visual Studio. There's an extension for Visual Studio Code as well called AWS Toolkit. And that'll come with all the templates that you need for creating, I'll say, just about anything in AWS. We'll just be focusing on serverless stuff today. But then it also adds in a bunch of hooks into Visual Studio so that when you're done with your code, you can basically just right-click on your code and say, yeah, publish this to AWS. Done. So highly recommend the AWS Toolkit. If you're more of a command line developer, they do have a .NET command line extension that you can install. So if you prefer to say .NET new, AWS Lambda, something, you can do that as well. But to keep it nice and simple, and also because I like this because I'm lazy, we're going to stay in Visual Studio here and check out this AWS Toolkit. So after you've installed the toolkit, the next time you go to spin up a new project, we can just filter for Lambda, and we can tell we want to create a new AWS Lambda. Sure, AWS Lambda 6, why not? And then once we've done that, we get all these options. So these are all the templates. So things like, we saw our S3 function just a minute ago, or if you want to do something with Kinesis, which uses streaming data, maybe you want to ingest video streams, and you can do all sorts of crazy things. So let's just tell we want an S3 function. And let's see if I can find the OK button. It's hidden down here. Or maybe, let's see if we can just change the display a little bit. Need more pixels. There we go. Let's do one a little bit better. Cool. Much nicer. So there's our finish button. OK, so this will create an S3 function for us. And when I open this up, it's probably going to look and feel pretty similar. Let's see. Zoomed out a little too far, maybe a little bit more. How about 125? Why not? So pretty similar to the code we already looked at. This gives us a class. It gives us a method here called function handler that takes in the S3 event, just like we had for our S3 trigger that generated the thumbnail. And that's it. Because again, remember, serverless functions should basically just be a method. Think of it as, well, it's called a function, right? So it's just one function, it's gonna do something real quick, it's gonna get in, get out. So here is that function handler in the template. We see that it takes in an S3 event, and now we can start writing our code, and then whenever we're done, back in our Solution Explorer, we can just right-click here, and now we have this option that says Publish to Lambda. So super, super easy. You just say, I want to publish this to AWS Lambda. We give it a name like NDC S3 demo. And I think there's one more thing I have to give it, like user permissions. There we go. So yeah, we'll give it an IAM role. And then once we click upload, our function's now up and running in the cloud. So highly, highly recommend that AWS toolkit because it just makes stuff like this super, super easy. Now, there's one more thing I want to show you because I'll bet a lot of us in here have existing APIs already. Well, there's something really cool that we can do with Lambda. So let's spin up a new project. So let's say we want a web API. In your case, you would just use your existing web API, but I need to slap one into this project to show this off. So we've got our standard ASP.NET Core Web API. If you ever build one, you're probably familiar with this template with a weather forecast controller. It's got this get method here. So we're not changing any of this code, but what we are going to do, we want to publish this to a serverless function. So I'm going to add a NuGet package, and I'm going to add in amazon.lambda.aspnet.hosting, or actually ASP.NET Core Server.hosting, and pop that into our existing web API. And then all we have to do to get this existing web API to run on Lambda, builder, services, add AWS. And we'll tell it it's a HTTP API. That's it. And so now we could publish this web API that we've had for years, and it'll just run on Lambda. Super, super cool, super, super simple. And the best part is, this line of code, when you run it locally, it does nothing. So you can still debug locally, you can still use it like you would, unit test it, put breakpoints in. This doesn't change anything. It'll still run on Kestrel, nothing changes. It's only ever used if it detects your application's actually running on AWS Lambda. Now, there is one gotcha here. So yes, just one line of code, but if we go back to our Solution Explorer here, and I right-click on this web API, you'll notice I don't have a publish to Lambda option here. I have a publish to AWS, this is a little different. So let's see what's going on here. Well, if we look at this, it thinks that I want to publish to Elastic Beanstalk, which is great. Nothing against Elastic Beanstalk. If you want to use it, go for it. But we're talking about serverless here, and there's no option here for serverless. So what we have to do is we have to help out the AWS toolkit just a little bit. So if we go back into our Lambda C# project, there's a line in here that says AWS project type. So if we just grab this line of code here, bring that into our CS_proj file for our existing web API, now the AWS toolkit goes, okay, you don't want Elastic Beanstalk, you want Lambda. And now when I right-click, there we go. Now we can publish it back up to AWS just like we wanted to. Cool. So lots of really cool things. Highly recommend jumping into the toolkit, playing around with it. And want to give you one more chance here. If you haven't already, make sure to take out your phones, grab a picture of this link, because this is where you can find information about everything that we talked about today. So the slides are here available for you. I'll include the video to this presentation once it gets posted up to YouTube. I've got links to the AWS toolkit for Visual Studio Code. And so everything you need to get started, you can find here at codetraveler.io/NDC-Lambda-intro. Thank you. Cool. So looks like we have a little bit of time left. Oh, no, you can go. That's fine. I was just going to say, if anyone wants to come up and ask any questions, I mean, it looks like we have a microphone. So yeah, why don't we start a queue? I'll give you the caveat that I'm pretty new to AWS Lambda myself, so don't ask me anything too difficult, but maybe we can all figure it out together. Do you want to come up first? Or shout it out, I can repeat it.
I was just going to ask you, in terms of the web API you showed there for sort of migrating to Lambda, like obviously that's great in a small scale solution, but is there any limitations you're aware of? We've got like a big existing sort of corporate web API and how well that would play with migrating to a serverless environment like that?
That's a good question. So yeah, it's like what if our web API is huge, right? So it would all exist under the same Lambda instance. And so if it's too big, we probably would want to break it up because let's say you got 20 APIs and 2 of them get used all the time and the other 18 don't. Well, every time your app launches, it's going to have to spin up all that code. So what would probably be better is, yeah, break those up individually. And then you can have those certain Lambda functions that get called all the time. And then you don't have to necessarily worry about, say, unnecessary charges and using too much. Because, yeah, I could see with the scaling, if folks start hitting all the different APIs, that it could start kind of going a little wonky with the scaling. So, yeah, I would probably chop that up a little bit, which hopefully isn't too difficult for you. But, yeah, good question. Cool, yes, please.
In the same context, let's say I have a web API which is running on scale, and I just want to make sure that the security, in this case, AWS has its own application proxy in front of it, in front of the Lambda running, right? I'm not getting it wrong probably, but so AWS Lambda runs application proxy in front of it, does it?
So I mean, the security you have set up will still be the same. So like if you need authentication, cookies, and headers, that'll still be the same. Is that what you're asking?
If I have to bring out an external identity provider into AWS for contacting Lambda, will that still work with AWS IAM? Or will there be a set of configurations that need to be done in order for
Yeah, I'll tell you this. I don't know, but yeah, I would assume you'd have to do some extra configuration to get, especially if it's external authentication to get that set up. Because yeah, when you push this stuff to the cloud, they kind of lock everything down by default. So I'd assume you'd have to give access to anything external coming in, but.
So there's no ability of using something like an API key or something which can provide access to AWS HTTP specifically?
I'm not sure. I haven't gone that deep into it, but good question. Does anybody know?
You can use the API gateway for that.
So basically, provide an API gateway in front of, provide the API gateway in front of the.
Right on. Thank you. Yes.
I have a quick question on the eventing side. Is there any like server-side filtering you can do? So you were getting all your events into the service, for example, and then having to
Yes.
extra warm start or pod maybe. If you can filter it before it went there,
Right.
is that possible?
Absolutely. So yeah, I was super lazy when I created this S3 trigger. I just said, fire on any new file. And yeah, I knew for my demo it would be fine. But yeah, what you can do, you can filter on file type, folder. So you can have multiple folders in your S3 bucket and only fire this if it's triggered by a file added to this specific folder, or only fire if it's a .png file. So yeah, you would definitely want to do that. That's a really good point, because yeah, otherwise you're waking up this serverless instance to just do nothing and go back to sleep. Good point.
When you configure that, is that all in AWS, or do you have configuration files you have in your code so you can monitor them for change? Or is it
I've only done it in the S3 console. Does anybody know if you could do that config in code?
Yep. Infrastructure as code, without permission, template for the Lambda, put it in a pipeline, run it through each time someone sets the pipeline, you have the configuration.
There we go. Any other questions that he can help me solve. Thank you, by the way.
Yeah, I've got one question there. If you're short of having a normal web API out there and make a modification and publish it to a Lambda, but that's something that it seems a bit strange to me. That doesn't seem to be something that I'm aware that Azure can do. So how somehow Amazon are better at hosting Microsoft products now than Microsoft? Or have I missed something?
No comment. Yeah, I'm also not aware that Azure can do that either. Can they? No? Cool.
One other question. Can we run containers on them?
Can you run containers? Yep, absolutely. I probably didn't scroll down far enough. Yeah, in that template, when you say file new project, you can specify like a .NET 7 containerized app. So yeah, totally. I personally stay away from containers because I'm just a mobile app developer. Those scare me. Awesome. Well, thanks everybody. Oh,
One last one.
sure.
On the stats, you showed about how much faster .NET 7 is with AOT.
Right.
But it was almost double without AOT.
Yep.
Right, that sounds strange. Is it just because that's now abandoned? You just shouldn't host it like that? And so Microsoft don't care anymore? Or?
So AOT's got its pros and cons. So in order to compile everything ahead of time, obviously your compiler is going to take a little bit longer, but your file size is going to be bigger too, because what's going to happen is it has to compile down all those base class libraries that we're using. So your file size gets a little bit bigger, and then there's a little bit of a concern, and kind of why Microsoft's not pushing AOT too hard right now is they do something called tree shaking, where they try not to bring in the entire .NET library and compile it. They try to just figure out what you're doing. But if you're using generics, like I'm doing a little bit in the app, a generic could be anything, right? So it kind of has to bring in all of .NET. So your file size is going to be a little bit bigger with AOT. Obviously, the compiler is going to take a little bit longer, but that's not a big deal. The only concern I would have right now with AOT is, test it, because maybe it removed a file or didn't compile a file that you need. But yeah, basically what it's doing is just essentially everything the server would do when it launches your file, like just in general, not even ignoring Lambda, ignoring serverless. AOT is basically just doing what a server would do when you say run ahead of time. So yeah, and apparently you get much, much faster time. So that's something I'm really excited about, but I'll probably wait till like .NET 8 till I really, really trust it. But yeah, it's a really cool technology. All right, great. Well, thanks everybody. Thanks so much for coming.